Hello, everyone, and welcome back to my channel. Today, we're delving into the exciting world of 3D printing and exploring the different types of 3D printers that make it all possible. I can't wait to take you on this journey. If you've ever wondered how those incredible 3D printed objects are made, you're in for a treat. We're going to uncover the mysteries of three key technologies: Fused Deposition Modeling, FDM, Stereolithography, SLA, and Selective Laser Sintering, SLS. Let's start with the most common type, Fused Deposition Modeling, or FDM. It's like the bread and butter of 3D printing. FDM printers work by melting a thermoplastic filament and depositing it layer by layer. It's affordable, versatile, and great for beginners. FDM 3D printers are a multi-billion-dollar market with thousands of machines. From basic models for children to sophisticated versions for manufacturers. You may occasionally hear FDM machines referred to as Fused Filament Fabrication, FFF, which is exactly the same technology. FDM, like all 3D printing technology, starts with a digital model that is then translated into instructions for the 3D printer to follow. With FDM, a filament, or several at a time, on a spool is loaded into the 3D printer and fed through to a printer nozzle in the extrusion head. The printer nozzle, or nozzles, are heated to the desired temperature, causing the filament to soften so that consecutive layers will join to create a solid part. Now, let's move on to stereolithography, or SLA. It's a whole different ball game. SLA printers use a liquid resin that's cured by a UV laser. This results in incredibly detailed, high-resolution prints, perfect for intricate designs and prototypes. SLA holds the historical distinction of being the world's first 3D printing technology. Stereolithography was invented by Chuck Hull in 1986, who filed a patent on the technology and founded the company 3D Systems to commercialize it. Today, the technology is available for hobbyists and professionals from a wide range of 3D printer makers. An SLA printer uses mirrors, known as galvanometers or galvos, with one positioned on the x-axis and another on the y-axis. These galvos rapidly aim a laser beam, or two, across a vat of resin, selectively curing and solidifying a cross-section of the object inside this building area, building it up layer by layer. Last but not least, we have Selective Laser Sintering, or SLS. SLS printers use a powdered material, typically nylon, and a laser to sinter or fuse the powder together. It's the go-to choice for durable, functional parts. Selective Laser Sintering, SLS, creates objects out of plastic powder by using a laser. First, a bin of polymer powder is heated to a temperature just below the polymer's melting point. Next, a recoating blade or wiper deposits a very thin layer of the powdered material, typically 0.1 mm thick, onto a build platform. A laser, CO2 or fiber, then begins to skin the surface according to the pattern laid out in the digital model. The laser selectively sinters the powder and solidifies a cross-section of the object. Each of these 3D printing technologies has its strengths and weaknesses. Whether you're a hobbyist, engineer, or artist, there's a 3D printer that suits your needs. But wait, there's more. We'll also talk about factors to consider when choosing the right 3D printer for your project, like build volume, resolution, and cost. I know this can be overwhelming, so if you have any questions or need more information about these 3D printing technologies, feel free to drop a comment below. We're here to help. Thank you for joining us today on this journey through the world of 3D printers. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more exciting 3D printing content.